There is a population of 50 goldfish in Hardy-Weinberg equilibrium. There are 3 phenotypes and 3 genotypes. The dominant homozygous genotype has a phenotype of a full tail. The heterozygous genotype has a phenotype of a half tail. And the homozygous recessive genotype has the phenotype of no tail. All 3 are seen in our population of goldfish. There are 16 full-tailed goldfish, 24 half-tailed goldfish, and 10 goldfish with no tails. We can calculate the frequency of the uppercase F allele by adding double the amount of full-tailed goldfish to the amount of half-tailed goldfish. Then divide that by double the population. We will get 0.56. We can calculate the frequency of the lowercase f allele by adding double the amount of no-tailed goldfish to the amount of half-tailed goldfish. Then divide that by double the population. We will get 0.44. We can tell the population is at Hardy-Weinberg equilibrium by doing a chi-square test. Through the chi-square test, we can see that this population is in Hardy-Weinberg equilibrium because the chi-squared test statistic is less than the critical value. This population of goldfish will go through directional selection. In this population, the full-tailed fish can get their food faster and easier. The half-tailed goldfish can still reach food at a much slower pace, whereas the no-tailed fish will have trouble getting any food at all since they cannot swim well. This will lead to more full-tail fish being able to reproduce. Typically, the phenotype frequency will resemble this graph, but with directional selection, the graph will move to look more like the red line than the blue. To find out the frequency of the alleles after selection, we start by finding the frequency of the phenotypes before selection. The frequency of full-tailed goldfish is the frequency of the dominant allele squared, which is 0.32. The frequency of half-tailed goldfish is the frequency of the dominant allele times the frequency of the recessive allele times 2, which is 0.48. The frequency of the no-tailed goldfish is the frequency of the recessive allele squared, which is 0.20. For selection fitness, I chose these numbers. To calculate the survivors, I multiplied the frequency of the phenotype before selection times the fitness. The new members are then added together to get the average fitness. To find the frequency after selection of each phenotype, I divided the survivors by the average fitness. You know this number is correct if all the frequencies after selection add up to 1. The frequency of the dominant allele after selection is the frequency of the full-tailed goldfish after selection added to half the frequency of the half-tailed goldfish after selection. The frequency of the recessive allele after selection is the frequency of the no-tailed goldfish after selection added to half the frequency of the half-tailed goldfish after selection. So here's the frequency of each allele before selection, and here's the frequency of each allele after selection. You can see how the frequency of the more fit dominant allele is higher after selection.